Hello, my name is Ingrid, and this is my final project for the course Machine Learning Foundations for Product Managers. The focus of this project is predicting the electrical energy output of a combined cycle power plant using machine learning. The goal was to build a model capable of predicting the net hourly energy output, called PE, based on ambient sensor data collected from a real power plant. This plant uses gas turbines, steam turbines, and heat recovery systems to optimize efficiency. The dataset contains 9,568 hourly observations of environmental variables. The project followed a classic 5-step machine learning workflow. Step 1. Define the type of machine learning problem and choose evaluation metrics. Step 2. Select input features and suitable algorithms. Step 3. Split the data into training, validation, and test sets. Step 4. Compare different models using validation data. Step 5. Final evaluation on the test set. Since the target variable is continuous, this is a regression problem. I choose multiple linear regression because it is simple, interpretable, and fits well with the data set. The data was manually split in Excel, 8% for training, 10% for validation, and 10% for testing. For evaluation, I used root mean squared error, mean absolute error, and mean absolute percentage error. For the first model, I used all 4 input variables: temperature, exhaust vacuum, ambient pressure, and relative humidity. A multiple linear regression model is built using the full feature set. After analyzing the impact of each feature using regression coefficients and p-values, I select the 3 most relevant features for the second model. This is my Excel sheet for the data splitting. I randomly split the set into 3 subsets: the training set, validation set, and test set. For the model 1 with all 4 features, this is the result and the coefficients of each input. I use the train set to calculate the coefficient, and then for my validation set, I calculated the predicted PE, the absolute error, and the percentage error. The final matrix was calculated for the validation set. According to the regression results of Model 1, I could analyze the results and I find the variable ambient pressure as the smaller effect to the output. So, Model 2 uses three inputs: temperature, exhaust vacuums, and relative humidity. This is the result for train set to Model 2. I find the coefficients and then I apply to the validation the set to Model 2 to find the predicted PE, absolute error, and percentage error. And there are the metrics. This table compares both models using the validation set. As we can see, both models have nearly identical performance. Model 1 had slightly better R squared and RMCE, but Model 2 was very close with only 0.03 difference in RMCE. Given that, I choose Model 2 due to its simplicity and similar accuracy. Finally, I applied Model 2 to the test set, which was never seen before by the model. The results shows that it's generalized well with low error metrics. In conclusion, Model 2 was the best choice. It's simple, accurate, and interpretable. This project shows how we can use basic machine learning techniques to solve real-world problems, even in complex environments like power generation. Thank you.